absolute value inequalities. Exactly what it sounds like. We're going to solve inequalities involving absolute value. So it's important to know there are two types of absolute value inequalities. We could have the absolute value less than something else or greater than. When it's less than, it is called an and inequality, and the answers will overlap. When it's greater than, it's an or inequality, and the answers do not overlap. Please make sure you write down those two distinctions. So let's run through an example, and let's think about what this is telling us. If we take our input x and subtract 4, we're going to get a number that's less than 8. Those will be the numbers in our solution set. So we could try a couple of numbers. Let's find out if, for example, is 0 a solution? Well, 0 minus 4 is negative 4, which is less than, and then the absolute value is 4, so 0 works. Let's do 4 as a solution. 4 minus 4 is 0, absolute value is 0, which is still less than 8. Let's try a bigger number, let's try 10. Is 10 minus 4, which is 6, absolute value, still less than 8. And let's try 12. 12 minus 4 is 8, absolute value is 8, which is not less than 8. It is equal to. We haven't tried any negative numbers. Let's try negative 4. Negative 4 minus 4 is negative 8. Absolute value is positive 8, which is equal to, not less than. If we tried negative 2, we would get the absolute value of negative 6, which is 6, which is less than 8. So we can see there are some values. Negative 4 is too far, positive 12 is too far, but the values in between seem to work. So let's get a more precise answer. So let's think about this. If the number inside the absolute value is anything between, well, if it's anything less than 8, the statement will be correct. But also, if we have negative values, let's say negative 7 would give an absolute value less than 8, negative 6 would give an absolute value less than 8. So we're going from negative 8 closer to 0. So we would actually kind of flip it around to think about the case when what's inside the absolute value is negative. That's a confusing way of looking at it. Basically what you're going to be doing is taking the inequality, taking what's in the absolute value, setting it less than 8, which is the original, and greater than negative 8. And then we solve by adding 4 to both sides, well, 4 to the middle, and then to both sides. And we get negative 4 is less than x, which is less than 12. Open hole, overlap. Try this on your own and I would like to know the lower bound and the upper bound. Just give the number answers because you wouldn't be able to type the signs in, but I want to know the lowest value that x could be and the highest value that x could be. Here's an example of an OR inequality. So let's again start off by testing some points. Don't need a teacher. Let's start off by testing some points. Let's see if 0 would work. 3 times 0 is 0, minus 2, negative 2, absolute value is positive 2. That one does not work. Let's try something bigger. Let's try 3. 3 times 3 is 9, minus 2, 7. That works. Let's try 2. 3 times 2 is 6. Minus 2 is 4. That does not work. So somewhere between 2 and 3 it starts working. Let's try some negative numbers. Let's try negative 2. Negative 2 times 3 is negative 6. Minus 2 is negative 8, which becomes positive 8. So negative 2 works. Negative 1 gives us negative 3. Minus 2, which is negative 5, and the absolute value of that is positive 5, which does work. So somewhere between 0 and negative 1, it starts to work again. What we're looking for here is the part inside the absolute value to either be greater than or equal to positive 5, or less than or equal to negative 5, which is exactly how we're going to set this up. We set up two separate inequalities with that word OR in the middle, and then we solve them both. Add 2, solving all of this simultaneously. So like we found before, somewhere between 2 and 3, and exactly at negative 1. So graphed. We're going to have closed points. Oops. And we're going to be less than and greater than. Again, try on your own. Tell me the two x values that will define the answer inequalities. So the lower x value and the higher x value that define our solution.